value inside of handle update is the same value as, let's go to Canvas UI, as sigmaNodesRemover, or this.sigmaNodesRemover inside of our Canvas UI class.
Okay, so inside Canvas UI, is it this one or is it this one that you were talking about?
Well, they're the same. This.sigmaNodesRemover is the same as this.sigmaNodesRemover.
Yes.
And what we're doing is we're calling the bind function on our function and passing a value of this that we want to stay constant no matter where we pass that function in.
We want it to stay this.
Yes.
And where is it here? Yeah, this?
Yeah. So this is a perfect example. Sorry, these lines of code right here, 120 through 128, they're another example of how the keyword this changes value depending on where you run the function. So here we have an array called sigmaIDs. Remember how there's a method available in all arrays called forEach? And that forEach method, it takes as an argument another function.
Yeah. But there's only one value in the array, correct? But
No,
I guess
the array has tons of values. We just call.
Okay, sigmaID is representative of tons of values.
No, it's representative of one value at a time. We run this function.
Okay, one value at a time. Yeah.
Each element of
sigmaIDs. Yeah.
And we call it element sigma. What I'm about to explain to you is actually totally irrelevant, so just ignore the tangent we're going on.
Okay. So we go back.
Yes, let's go back to Canvas UI. All right, so now now we need to pass in into the callbacks list inside of OBJ. We need to pass into obj.onUpdate. We need to pass in these two functions. So yeah, delete line 24 and use line 23 instead. Because 24 was not bound. 23 is bound.
Okay.
It has the value of this bound into the function.
This is unbound right here?
This is unbound.
I'm sorry, the one that is highlighted is bound.
The one that is highlighted is not bound.
Okay.
See, and then the ones on line 21 and 22, those are bound.
Yes.
We call the .bind method, passing us an explicit value of this to stay constant.
Okay. So, delete this.
Correct.
Is this one here, 23, is this bound?
This is bound. Because you defined it on line 21.
Okay.
By using the .bind.
So should I just copy this for remover?
Yes, exactly.
Boom, boom, boom. If anything, I'll know how to just make a feature that's kind of already been created because I just copy it.
Yeah.
Okay.
All right, so let's save this file. This is such a tricky word now because it means, yeah.
I'll never be able to learn it. Never be able to use it the same.
Yeah. Okay, so let us look at this type of update we're receiving.
Okay.
So yeah,
like this?
Click on that. So it's very obvious what properties are available in this type of update. Type is one of the properties. ID is another property, and val is the third property.
Okay.
It's type and ID and val. It's a really explicit interface name.
Now, how do you know that they're all, just because they're all in this whole file?
Well, yeah, command click on this. It's going to take you up to here.
Oh, okay. Extends that. Oh, okay. Nice.
So, the interface, it has ID. It has
val.
Yeah, it has type and it has val. Type is going to be, it's going to take a set of values, and those set of values will be defined in this type. So command click on that. Custom store data types. Yeah, it's either going to be the string, tree data, or it's going to be the string content data or tree location data, etc., etc. Go back to where you just were, control minus. what we want, okay, in that val, it's literally going to contain the entirely new value for that type of object. So remember how for our tree objects we have 3 properties, right? What are those 3 properties?
Tree ID. No.
Parent ID,
Parent
content
ID.
and children.
Okay.
The
Parent
object
ID.
itself, well, we have another interface that's similar to tree that has tree ID in it, but this one doesn't.
Okay.
So for all intents and purposes, it just has content ID, parent ID, and children. So anytime one of these properties updates, like let's say the node gets a new parent or gets a new content put on it,
Mm-hmm.
or one of the children changes, which is our case, the entire, all 3 values, they get published as an update from our store, and then Canvas UI subscribes to that update. That update gets passed as an object into our .handle update method on sigmaNodesUpdater and on sigmaNodesRemover.
Mm-hmm.
What we want to do is, like you said a few days ago, we want to look at the children property and see if the children property changed from what it was before. If it did change, we will tell, like if one was removed, we will call the .remove node method on sigmaNodesRemover. Alright, let's see if we're doing all 3 of these. This is gonna be interesting.
Alright.
Are we doing different rotations?
I'll start here.
Alright.
Guys, starts to see like 2, a few, 3. This girl's looking at it, it's like, fuck.
Alright.
I forgot to say
So
that.
So these
You can't conform to social norms, John.
These guys are changing. They aren't even looking. They've given up on it. We're at 9. And I'm sore.
7. Oh, this is hard.
11, 12. I don't know if I need to hit the
8.
10 anymore if we're gonna be doing this.
Seriously.
14, 15,
Oh, this is bad.
16,
3.
17, 18, sweating already, 19, 20. Alright, where are these times? Dude,
Wait, I need to do something to push
thighs
that.
are freaking sore already.
I'm like I feel like such a bitch. 5 push-ups. I mean, shit. I'm like winded.
Just like 4 up in the squats.
People watching this video are like, what the hell is going on?
8. Last count. 15 fucking 12. I'm good at the pushing.
Damn, you've been doing your push-ups.
This would be fucking brutal, man. Holy shit.
All right, we'll see. I say we commit to the next one. And we'll see what we'll see what happens after that.
It'll probably be the on by then. Yeah.
Okay.
Alright.
So, like you were saying,
We need to, inside of sigmaNodesRemover, somehow, based on receiving this update, figure out what we call sigmaNodesRemove from some other function, some other
shit, we lost our train of thought.
some other object we created. We created some other, we added some remove node function. I remember you doing this. You added a remove node function on one of our classes. We need to call that function on the right node ID based on the change in the children properties in this update we received. The hard part is going to be figuring out what child changed inside of the children property. One way to do that would be keep track of all updates that ever happened and keep track of the old children properties on every update that comes through and look at when the new children changes.
Mm-hmm.
That might be doable. That might be really hard. Alternatively, this might be easiest, and it might not slow down our app too much. Anytime we receive an update object for a tree, we go find that node, we find that tree, we look at let's say somehow we remove all the old children, no matter what, on that old tree. And then we just add all the new ones. So if there were 4 before, we remove all 4, and then we look at this new set and just add all 3.
Okay.
The question is, how do we remove the old 4 if we no longer have the children right before them? Now we just have 3, so we still don't know what the 4th was. So it's like we need, I think, unless I'm looking this wrong, we need to keep track of what the old state of children was, no matter what.
Only the second most recent one, or all of them of all time?
Just the most recent.
Because if you delete one, it knows that one was deleted. I just don't. Why can't you just go in there and erase one of them? They hit delete and it just erases it. There's just so much code that there was so much involved in it that you can't just simply delete it. You have to write more to delete everything that was ever had to do with it.
We could simply delete what was there before, things we don't know. We could delete all the children nodes that are there before. We just don't know the children nodes that are there before. Because we're only getting past the new children.
Yeah. So if we have a set of 4 children and we delete number 4, will it just have 3 children? I don't think it might be any help because I don't really understand.
What I'm saying is, on
Yeah.
the map, so this is.
Just throw that one away.
Yeah.
Just like leave the cab off or something.
We should get our own trash can in here.
That's the corner, the trash
the
corner.
corner, the dance corner. This is the parent node, child node 1, child node 2, child node 3, child node 4. So these all exist in the map. They all have IDs. This will be ID 1, 2, 3, 4, 5. If at any time we were to call whatever class we had .remove node and pass in 3, it would remove the node with ID 3. Work for any one of these nodes. Thing is, let's say the user clicks action, the user clicks the delete button on 4, it updates their store, the store publishes an update called this is the new value tree.
Mm-hmm.
The new children are going to be 2, 3, and 5. I think we can do this. I think we automatically do have the old value children in there. Okay. So, it just so turns out that we have an object called sigmaNode. sigmaNode, inside of it, every time there's an update, receives the new value from that update.
Mm-hmm.
So inside of sigmaNode, we have a property called tree data. Tree data, in our case, will contain as a property under the property content ID, parent ID, and children. The thing is, the tree data property of sigmaNode, put them in. You want to join our exercise circuit?
Every 20 minutes.
Every 20 minutes, you got to do 20 squats, 8 burpees, and 50.
Keeps the blood flowing.
That's a startup.
Dude, we were winded after last one. We have another one in 14 minutes just before
Iris. Push up a little bit so that. Anyways, I was wondering, do you know anything about dynamic programming?
Yeah.
Okay.
Which problem are you doing?
No, I'm just not.
Dynamic programming is a fancy word for recursion plus caching.
Yeah. Okay.
Yeah.
Yeah. Like, I just don't get dynamic programming. There's a shit ton of like problems.
Yeah, those ones are fun. You ever do like the steps one?
The only one I do know how to do is find like how many unique ways there are to like navigate like a
Checkerboard.
checkboard.
Yeah.
That was like.
Yeah, I mean all of them follow the same principle.
Yeah, it's like like how do you get better at it? I guess. Practice.
I'm not an expert at it. I just don't do the basic ones.
Okay. Just fucked up.
I never interned at one of the big companies because I never studied CTCI until I wasn't trying to interview for them. I was helping a friend study.
Gotcha. What are you guys working on?
We are.
Is this
We're
Java
actually-
or something? This is not Java.
We are doing something that this is TypeScript. It's similar to Java. We're doing something that involves recursion and caching, but it's not dynamic programming. They're used several times.
We're adding a delete feature. Because we can add as many nodes as we want.
Did you ever change your UI?
No,
You need to change your UI.
we're working on that.
But
Our
but
grade's
but
gonna do that.
but the goal is to get people to use it no matter what. Because if
Yeah.
we can't get people to use this, then we can't get people to use something with nice UI. But it gets fucked when you try to move something and it's not all loaded.
That's
we
not
just have
true though.
we
I feel
just-
like UI is like a huge part of writing around people
For sure.
like.
We're getting there, man. One thing at a time.
Yeah, true.
We're not experts.
No, but I don't know. We'll see. I mean, it's not like people are gonna. shoot
we have
us
a
if
paying
it's bad.
customer right now. He's paying $10 a month.
Wait, who?
Patrick Sweetman.
Oh, nice.
Yeah, do you know him?
We had lunch.
Oh, that's right. Yeah.
Dude, that is intense.
He is intense. I'm working on a project for one of his clients right now. I don't know if he gives positive feedback, man. It's only
One of his clients?
Yeah.
He has clients.
he makes bank.
Yeah. For contracting?
Yeah, Patrick. I'm not sure if he gives positive feedback. It's really intense, man. I feel.
What do you mean he does? He's like, John sucks ass.
I guess. I mean,
Yeah.
like if I do something really boss, I just go into the next thing, and then if you make one mistake, it's that was wrong.
He's one of those people.
Yeah, which is good. He's a taskmaster. And he's really efficient. But for someone with emotions like me,
Yeah.
I feel bad, man.
Mm-hmm.
But yeah, that dude, talking to that dude, like, he's intense as fuck.
Yeah,
Great guy though.
yeah.
How old is he?
I don't know, cause he did something military for a while, right?
Yeah, he looks older.
Yeah.
I guess age doesn't matter.
I mean,
He's
it's just
just
a
an
number.
info.
Yeah, it's just a number.
All right.
No, I was just wondering. I'll leave you guys to it.
Hey, bro, do you want us to hit you up in 11 minutes?
Sure, yeah. Just
Send me
call me
over.
over. Just like wave at me. And
All right, cool.
You'll
I
see us
just
get
did- I
out.
just did back pay today.
We built. All right. So every time the sigmaNodes updater, that handle update method gets called, what happens is the value of this update literally gets assigned onto the tree data property under sigmaNode. So before the sigmaNodes updater, that handle update method gets called, we still have access to the old values.
Mm-hmm.
So we just need to call the remove update method, the handle update on the remove updater, before the handle update method on the nodes updater.
Okay.
And then we'll have access to the old values.
Okay.
So let's go back to Canvas UI.
So you just if you hit delete, but before it actually deletes, it saves it and then it deletes it or something. Basically.
But before we overwrite the old values of
Yeah.
tree data,
Yeah.
we look at the old state of children,
Yeah.
compare a diff, look at the difference between the old state of children with the new state of children, figure out which node we deleted.
Mm-hmm.
Well, we figure out if we deleted a node, and if we did, we figure out which one,
Mm-hmm.
and then we call remove node on that.
So go back to where?
While we're at, did you boot up your local host and can run it?
Mm-hmm. Oh wait.
Local host.
Yeah. I should do this in my terminal, right?
Oh, it's already, yeah, it's
Or
already.
no?
Or no, it's not. You cancel it. Go back to terminal. It's not running right now. Hit up. And Let's type npm run dev.
Ooh.
Oh, it says it's already running? Oh, we
Right,
gotta boot
Docker,
up Docker.
yeah.
That's weird. I thought Docker always auto started when you turn on your computer.
I think I closed it
Gotcha.
earlier this weekend. Poop. Now it's gonna take like 5 minutes to upload to start.
Docker took like a minute last time. Well, the npm run dev, yeah, that takes like 5 minutes. Alright, anyway. While we're waiting on that, we can start editing. Yeah, it's not up yet.
Okay.
We can start editing the files. We're going to. Let's go Canvas UI. And we need our remover handle update to be added into the callbacks list before the nodes updater handle update. So to swap the order of 23 and 24. Now this assumes that the order of the callbacks that receive update calls goes in order that they were added, and I think it does. We'll figure it out. Alright, so hit save. Now, let's go to sigmaNodes updater.
Wait.
Oh man, this is gonna be fun. Alright, scroll up to the top. I want to see what objects sigmaNodes updater uses. So it uses.
All of these are the objects that it uses.
Nah, 38 through 45
Okay.
are all the properties that are inside the sigmaNodes updater class. Okay, so we want to copy lines 39 through 41. And I think that's it. Yeah. Alright, and let's go with sigmaNodesRemover. Let's go up to the top. Let's delete all of 38 through 45 and paste what you just copied. Alright, and then while we're at it, let's make those three properties the only properties inside of our args object. So,
Okay, so
like
here,
these lines,
yeah.
just type sigmaNodes.
Nodes, edges, render manager. So get rid of this guy.
Yeah. And then the last 5, that's 4. Yeah, that's 4. Yeah, that's good.
Close bracket, probably.
No, you already have the from bracket on line 47. It's
Okay.
at the start of line 47.
Yeah. Mhm.
And then let's remove all the red underlines inside of the constructor body. Yeah. You do want Sigma Render Manager.
Yes, I do.
Yeah. Alright. And then let's scroll down to the bottom where we define our sigmaNodesRemover args. And delete everything that is not Sigma Render Manager, sigmaNodes, or sigmaEdges. So yeah, delete the first one, lines 120 through 122.
Okay. Oh, because you have nodes, edges,
And
render
Sigma
manager.
Yeah, so you can delete 126 through 131. Yeah, there you go. And then line 120, we have a straight slash, backslash. Alright, so let's save this. And then let's define handle update to be what we want. So inside of handle update, we want to
Where's handle update? Is it in here?
line 104.
Okay.
Okay. So we want to. All right. So sigmaNodes, that's an object that gets injected into our remover args class. See, yeah, on line 121, we inject types that sigmaNodes. We want to make sure that that sigmaNodes object that gets injected is the same as the object that gets injected into sigmaNodes updater.
Mm.
And I'm not sure if it is because we don't have a tag. So it might not be set up correctly in our Inversify config. So let's go to Inversify config. Look for types.iSigmaNodes. .iSigmaNodes, yeah. Alright, you hit enter. That's not it. This is it. Okay. Aha, I have a 2 expecting that this would happen. So, I'm just curious. I could have sworn I had already injected the sigmaNodes object into multiple classes. But maybe I haven't. Or maybe I haven't and there's a hidden bug that we don't know about.
Mm.
Oh, man.
Well, we have some digging to do, don't we?
Yeah. So do a command shift F, global search for types.iSigmaNodes. Alright. So store.ts does not use it. Render Manager Core does use it. sigmaNodesRemover uses it. sigmaNodes Updater uses it. And store source. Oh, no, that doesn't use that comment. Let's go there. Let's go with that comment.
This one?
You click one.
This one?
Yeah. Let's delete that comment. No one wants that comment. Alright. Let's save this file.
Okay.
Alright, so let's go back to Inversify config. What I'm curious is, alright, see how it's bound to a constant value,
Mm-hmm.
and that constant value is an empty object? What I'm wondering is the way it works is every time we try to inject types.iSigmaNodes, does it give us a new empty object, or does it give us the same object each time? And I don't really know. So I'm pretty sure it's giving us the same object each time because we don't have any bugs in our code, and I'm pretty sure it works fine. But what we could do, instead of adding debug statements in our code, we could look at the documentation of the library we're using. So let's search for Inversify.js
P.
inside of Google. My bad.
Meantime.
Oh no.
Hmm.
Oh yeah. Try and get my code. Yeah.
Yay. What am I searching for?
Inversify.js. Alright, you click on the first one. You remember GitHub?
I mean, I have a GitHub account. I made it like maybe a year ago. Never ever used it, but
Awesome. Do you know your GitHub username? Because I'll add you to your branch.
I think we did.
Oh, we already did that. Alright, cool.
Yeah. I'll check, but should I sign in?
Sign in while you're at it.
It's definitely my Gene right now.
Because once you make, so after this first feature, I'm gonna have you start following standard Git practices. So after you make every change, you're supposed to make something called a commit, where you mark the change you made so that developers in the future can see when you made that change
Yeah.
and kind of undo it if they want. Alright, let's get the boy lead on.
Time is home.
It's time.
Yes.
Is he coming?
He's coming.
I don't know the login. I have Kanye. Hell of a life. Play some trap music.
With music.
Oh, we have.
Wait,
I miss the old Kanye.
What's the drill? 20 body squats.
Here we go. Alright,
Pick
so
your station.
I start at 15 push-ups. Alright, ready?
Are you
When the beat drops. When the beat drops.
8 burpees. Alright.
Here we go.
Dab. Dab. You have to dab at the top of every burpee. Alright, well, how many spots do you have? Oh shit, I don't know. I'll just do 20 more. Alright, I'll just keep going for you. Alright, let's say. Alright, I'm just leaving. Eight. No, 15 push-ups. Alright, you, one of the people haven't finished the surgery yet, you gotta keep going. Alright. 20 spots. Okay. This is my weakness right here. Shit. I gotta start doing more push-ups. This is good. Okay, I'm done. Oh, you still going? You gotta keep going. How many you have left? 17. 18. 19. 20. Oh, ah. Whew, thanks for running.
That's good. That's good.
Good set, boys.
How many reps have you
Was
guys
this
done?
our first one? This is our second. That was our second one. Well, we did like half. We did like half.
Nice.
2.5. Alright, we'll see you time on the thing.
Alright. Are you guys trying to ice or something?
Yeah. I'll swing by. I don't know if I'll stay the whole time.
Some food.
The food?
Yeah, pizza.
I'm not gonna eat it.
Why not?
I'm really healthy.
Yeah.
I'm like tubby.
Oh, shit.
Yeah, I packed some veggies and fruits.
I'm good. Yeah, I'm done for the day. I'm good for the day.
Damn, that's conviction.
Yeah.
I wish I did not have.
I'll see you in a minute.
So, you go sigmaNodesRemover. Up there? Is that where we're at?
We were Googling.
Yes. Oh, yeah.
I was logging into GitHub, but
Yeah.
we'll do that later.
Let's go through. Well, we
We were looking up
Let's go down.
Inversify JS.
Yeah. So we need to find documentation for that .2 constant value method. So keeps going down. Let's go down quickly. Alright, scroll a little. Here we go. Let's go down a little more. Injecting a constant or anything like that.
Injecting a constant.
Or dynamic value up here. Scroll down. Oh, it does not explain shit. I think it does literally just create one instance. That'll make sense. Like what they're saying here is anytime someone says add inject katana, they'll get the same katana that is created right here.
Mm-hmm.
So yeah, if it weren't doing that, our app would not be working. So we're good. We don't have to modify our Inversify config.
Okay.
Let's go back to sigmaNodesRemover.ts.
Come on, RJ, you can do it. Yeah.
Alright, so that's all good. Yeah, so let's go handle update. So update, what properties does it have available on it?
This.
Yeah.
What properties are within iType?
Yeah.
Is that what you mean?
Yeah. It's literally in the name.
Okay, so
Type
ID and val.
Yeah. Yeah. So we want to get the ID from update. So it's going to be available as update.id. And then we want to search the this.sigmaNodes object. Fetch the sigmaNode object. Ooh. I'm really curious. What is this defined to be?
This.
And click on sigmaNodes. It's a hash map. Let's go to sigmaNodes updater. I want to see how their handle update method works.
Sigma nodes updater. Sigma nodes.
Yeah, updated.ts. There you go. Scroll down to handle update. Okay. So, all right, let's look at this. Okay. Gotcha. Cool. Alright, let's go down to update Sigma node. 141, just go down a little more. Alright. Let's go to sigmaNode.ts. Let's go down. Alright, here we go. So, see how we have a method called receive new tree data. What it does is we have an object called sigmaNode that stores all the information about the node, including the content ID, parent ID, children.
Mhm.
I was just verifying something. It is how we want it to behave. But this right here was essentially what I was talking about right here. How we essentially have under sigmaNode the content ID, parent ID, and children, and they get updated every time sigmaNode's updater calls handle update.
Mhm.
Let's go back to sigmaNodesRemover. Okay. So, you can delete lines 105 through 114. Just delete the whole body of the method. Okay, so we're going to create a new variable. It's going to be constant assignment type. So
Should I
const,
indent?
yeah, that's good. So const sigmaNode. And give it the type of iSigmaNode. Whew, I'm sweating, man.
I know.
Is there a shower in here?
That's gonna be it's gonna be an issue. We're just like shit.
Yeah, alright, yeah. So is equal to this stuff sigmaNodes. Okay, we're gonna introduce a new concept. This is something called a hash map. We don't need to say hash map. We do. Command click on iSigmaNode. Actually, not that. Command click on iSigmaNodes 112. 112. And
Okay.
112.
Here.
And iSigmaNodes interface. Okay. So see how it says iSigmaNode is equal to iHash plus sigmaNode. Command click on iHash. Alright. So hash, that is a fancy word for object. You already know what objects are. They are things with properties and values. And they are denoted through this syntax. So we can say const A is equal to, property 1. Let's say the value is high. You can comma property 2. Let's say this property 2 is a number. You're familiar with that, right?
Mhm.
It turns out that you can access the properties through two ways. One way you're familiar with, that's where you do object name dot property name. So a.prop1, that's going to be equal to I, right? A.prop2 will be equal to
75.
Yeah. There's another way we can access the properties on hash map, on an object. And that is through using the following syntax. Rather than dot property, we do bracket, quote, property name,
Prop1.
quote, bracket. And that is going to be equal to the string high.
And in JavaScript, you can use either single quotes or double quotes. You do the same thing. Maybe like, all right, so why would we ever access the property through this syntax? Typing dot property name is much shorter than bracket quote property name. Sorry, bracket quote property name quote bracket. It's like 3 less characters. The reason for it is, let's say you don't know the property name. Let's say the property name is itself stored in a variable. So we could say let prop name equal prop1. Well, now prop name itself is a string equal to this value right here. So if we did a prop name, the JavaScript evaluator, the JavaScript interpreter, essentially transcribes that into a quote prop1, which in turn gets evaluated into high. Does that make sense?
And prop name could be, since it's a let, prop name could be changed.
Exactly. So now if we were to do prop name is equal to prop2. Now you know this can be named by anything. They can have a property called like height.
Yeah.
Right, yeah. If we did prop name, prop2, and then a prop name, this will be equivalent to the value
75.
75.
75.
So, in TypeScript, we created a type called iHash. And iHash is the same as an object. It takes properties, and each of those properties is defined to have a value. Well, it turns out that TypeScript lets you define an object type such that all the values themselves must be of a certain type. So in our case, did we explain generic types? I think we did. I'm not sure if I ever used the word generic type, but I used we should head upstairs. I use the phrase type arguments. So here we have a type called iHash, and it takes one type argument, and that type argument is given the variable t.
Yeah.
T can be set equal to anything. We could set, well, when we're calling the interface, we could set t equal to string. We could pass in int as t. We could pass in sigmaNode as t. We could pass in person as t. We could pass in whatever type we want into that t value. So we could, for example, create a type called interface sigmaNodes and say that sigmaNodes extends an iHash type that takes the type argument of what would you guess?
Shoot. What is the one with the 3? It's the one with whatever has 3 properties. Those 3 properties.
Yeah, so I won't expect you to answer. It's actually going to be a type sigmaNode.
Okay. I failed you.
I never even explained to you what sigmaNode was, so you shouldn't really know how to do this. So sigmaNode is an object, or it's an interface that says all objects that conform this interface must have 12 properties. 3 of those properties are content ID,
Yeah.
ID and children, and there's another 9.
Yeah.
So what will happen is if we create a new constant called sigmaNodes, and we give that constant, that object with the constant assignment type, we give that object the type sigmaNodes. Well, we know sigmaNodes is a hash. Hash is a fancy word for object, but more specifically, it's our iHash type is an object saying that all values that are associated with properties must be of a certain type. So if we were to say that our first key value pair, let's say
This was node 1, 2, 3. Whatever comes on the right side of this colon itself must be another object that conforms to the I sigma node type. I sigma node type has 12 properties on it. One of them is parent ID. Parent ID must be a string. 4. The second property this must have is content ID. So, 5, 6, 7, etc. We have all these properties that the object, so that the value.
1, 2, 3 is the object, and it has all
1, 2, 3 is the key.
key ID of the object.
Yes.
Yeah.
The value. All right. So yeah, here we have the key. Here we have the value.
Ah.
Rather than having a simple type, rather than having a string, we're literally having another object.
Yeah.
All right. So now we have a comma after the value. Now we're going to add another entry into our object. So we're gonna add another key. Let's say this is node ID 1, 2, 4. So if we were conforming to our interface, again, we'd write out another object that has 12 properties. Let's throw an error. Let's say rather than putting in an I sigma node object, we put in a string. Hello world. This is going to throw a TypeScript error because hello world is not what type?
Hello world does not conform to I sigma node.
Exactly. Yeah. So that's what the I hash type does. So let's go back
It
to
makes sure the I hash makes sure that all of the values in the const sigma nodes conforms to sigma node, I sigma node.
And it also does a second thing which I never stated explicitly. It says that all the keys, all the things on the left side of this colon must be of type string. So if we try to, let's say, add a third entry, or let's say our second entry was, so this is a string because it's in quotes.
Yeah.
Let's say it was an integer, like 23. And then we actually did have an object with the correct 12 properties. There would still be an error thrown.
Yeah.
Why is that?
Because it's not a string.
Exactly. 23 is not a string.
Yeah.
Yeah. So the keys
It's in
must be
quotes.
strings.
It's a string, not an integer.
Exactly. So yeah, the keys must be string, and then the values must be of type T. In our case, type T is I sigma node. It's good. It seemed to pick up.
And the difference between an integer and a string is a string is just the name. It's not. It's kind of an identification, whereas an integer could be some sort of number that could be put into a math equation or a method.
Exactly.
Yeah.
Yeah.
A string isn't a number, really, right?
But the way strings.
multipliable.
So
whatever.
you know how fundamentally, what's going on in computers is there are a bunch of ones and zeros.
Yeah.
So it turns out that every character you type in a computer is represented by
Ones and zeros.
a list of ones and zeros. So quote 1, 2, 3 will actually be represented differently in the computer than just 1, 2, 3. Because computer will fundamentally give a different list of zeros for the string, the list of characters that are 1, 2, 3, rather than the numeric platonic value of 1, 2, 3. Yeah. All right, let us go. That's that.
All right, what time do you want to leave there? Do you want to leave early?
I don't want to stay for more than 5, 10 minutes.
Okay.
And it will.
Yeah.
And they're probably having a group activity.
No, they are, for sure. But we could just say, oh, we have.
Yeah, we'll have to say